Okay, so alcohols and ethers. Alcohols are the next class of compounds we're going to talk about. The functional group of the alcohols is the OH group. Now, a very important distinction is that the class of compounds, if you had this molecule here, methanol, the class of compounds it belongs to is called the alcohols, but the OH group itself is actually just called a hydroxyl group, and you are expected to know the difference. So one is the functional group itself, and one is the class that the whole molecule belongs to, so alcohols and hydroxyls. You can have one or many hydroxyl groups on a molecule. Most of the examples you'll see have one, although sometimes the IB throws one at you with two, and in that case you can call it a diol for having two alcohol groups. They look a lot like alkanes, except they have OHs instead of one of the H's. And so this is ethane and this is ethanol. Now, if we're going to talk about IMFs, a key difference, as soon as you see that OH group, you should recognize that that's one of those HNUF things, and therefore alcohols are known for having hydrogen bonding. So they tend to have fairly high boiling points and melting points, even when they're quite small. So just like with halogenoalkanes, depending on where the OH group is, you have to number it. With methanol and ethanol, you do not need to number the OH group because there's only one position where it can be, the number one carbon. But as soon as you get to 3 carbons or more, it's going to require that you number it. And so with these 3 alcohols here, the first one we would call 1-propanol or prop-N1-ol. So not porp, sorry. So there's 2 different ways to write the exact same name. Both are acceptable. You can either call it 1-propanol. The 1 is telling you where the anol is, which is the ending for alcohol groups. Or you can put the 1 right in front of the ol to be even more specific. So 1-propanol or propan-1-ol, you'll see both on the IB exam, and you can use either when you give a name. The next one here, because it's on the second carbon, would be almost the same name, except the 1 would be replaced with a 2. And the last one actually has the exact same name as the first one, because this is the 1 or that's the 1. It just is a matter of perspective. So there's only 2 isomers there. If there is more than one hydroxyl, you would have to number them both, 1,2, and you'd call it diol. So ethane 1,2-diol or 1,2-ethane-diol. A very rare example, but just wanted to point it out. We're going to skip past the physical properties for now. We can discuss them and review them in class. Classification, we've already discussed this with halogenoalkanes. You can describe alcohols as primary, secondary, or tertiary based on the same criteria as the halogenoalkanes. And so this first one would be a primary alcohol based on this carbon with the OH group being attached to only one other carbon. We've got one that's secondary here, and we've got one that's primary here, and then we've got one that is tertiary here. If you have questions, please bring it up in class. One very important use of alcohols is that they combust readily, and they can be used as fuels. However, if you look at their combustion values, their enthalpies of combustions, they release significantly less energy per mole than the corresponding alkanes. And it has to do with the fact that they already have some oxygen on them. They're already partially oxidized. So if you were to compare the enthalpy changes in an alkane reaction, the original alkanes have more stored energy than alcohols do. Alcohols, even though they have the same products of their reactions, the enthalpy is actually a bit lower for alcohols, and alkanes have a higher amount of stored energy because they have no carbon to oxygen or oxygen to hydrogen bonds. So the change when you burn an alkane gives you more energy out than the change when you burn an alcohol. So alkanes are a little bit better fuels. But you should be able to write a combustion reaction for either one of these, and we can do that in class. Ethers are a class of compounds that are going to have the same chemical formulas as the alcohols, but they have a different functional group. So this chemical formula, C2H6O, you can have an alcohol with that formula, which is ethanol, CH3CH2OH, or you can have an ether that has that chemical formula, and it's a very different type of compound. So the functional group for the alcohols is the hydroxyl group, an OH group. The functional group for an ether is that there's an oxygen single bonded to carbon chain on either side. Either side. The ethers have carbon chains on either side. So that's kind of the way to remember it. So this is what an ether has to have. An oxygen single bonded to carbons on either side. The name of this one is ethanol. The name of this one is a little tricky. It's called Methoxy Methane. Whenever you name an ether, you sort of treat this as a group, and you call that by the number of carbons plus oxy, so meth, and then oxy for the oxygen. And then you name the longest carbon chain like the alkane. In this case, they're both the same length, which is why they're both meth, so methoxy methane. But if this was a 2-carbon chain, we would call it methoxy ethane. The name of the functional group is a hydroxyl, and this one is an ether. And if we compare their IMFs, alcohols can do hydrogen bonding, whereas ethers just have some very weak dipole-dipole forces because they don't have O directly bonded to H. So alcohols will have higher boiling points and melting points and be less volatile than ethers. But actually, they're both fairly water soluble. The alcohols will be more so, but ethers will also be water soluble because they do have that oxygen, which can form hydrogen bonds, not with themselves, but with water molecules. And we'll do some practice drawing ethers and alcohols and their isomers and naming them in class.